Hello, 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 and welcome back to the channel. Today, we're on day 15 of our Leetcode series. So let's just hop right into it, yeah? Today, we have Leetcode 3443. It's called the maximum Manhattan distance after k changes. We're given a string S consisting of the characters north, south, east, west, where S of I indicates movements in an infinite grid. North, okay, yeah. So just the directions, they move 1 unit in that direction. Initially we're at the origin, we can change at most k characters to any of the 4 directions. Find the maximum Manhattan distance from the origin that can be achieved at any time while performing the movements in order. The Manhattan distance between 2 cells. The first cell with x coordinate xi and y coordinate yi, and x coordinate xj and y coordinate yj is xi minus xj plus yi minus yj. Okay. For the example problem, we're getting north, west, south, east, so just 1 in each direction, and we can change 1. We can change 1 of the directions. So the max Manhattan distance after changing one of the directions is 3. As we change south to north, north, west, north, east. Would that not just be 2 though? North, west, north, because west and east cancel each other in 2 norths, right? Oh, you have to... Okay, so you keep the maximum distance after each time, so the end result is not the final result. Interesting. That actually makes it a lot harder. That does make it more difficult. North for north, south, west, west, east, west. We change south to north and east to west. The string becomes north, north, west, 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 west. This seems pretty difficult, yeah? What's the algorithm to find out what you need to change? Is it just brute force? That's all I'm thinking of right now. Sure, it's a median problem, but it only has a 47% acceptance rate. The last one we did had an 80 and it took me 45 minutes, so I'm kind of scared. I think we need a hint. Okay, sure. We can brute force. Is brute force really the option, though? Change up to k characters to maximize the distance in the chosen direction. Yes, I would happily work at McDonald's. If and else. Okay. Is it really just brute force? That seems super slow. And the length can be up to, was that 10,000 characters? So the, wait, so the total distance is just the absolute, wait, let me just make sure I know what I'm actually doing. Xi minus xj. So it's really just the absolute value of 2, 3, 2. I was thinking about keeping like a counter of each direction and how many times it's in the string. But then I don't know what the algorithm would be of what to choose, right? What character or what direction to choose or switch. Because if I'm given north, west, south, east, each being 1, I don't think it really matters what you choose for this one, because they're each 1. They each have a count of 1. But for this, north, south, west, west, east, west, there is 3 west, and then 1 of each. So obviously you would change this to west. Wait, I actually think it's not that bad. Because you just want to change, you want to see the count of each. And obviously, north and south oppose each other, and then east and west oppose each other, right? So we need to minimize opposing direction. Okay. I think we obviously need a dictionary, right? We need a dictionary containing all the elements, I would assume. North, 1. South, -1. Wait. I would assume. East, request -1. And then I also would think we would need to split the string into, or maybe we could just do 4 care cares. Let me see if we can do that. If we can just do a for each loop for the string. We can. So that's probably what we're going to do. Okay. So we go through each character one by one, right? And then do we just add it to the counter, yeah? There is a library for counters. Can I just do that? Would that work? Oh my god, that makes my life so much easier, doesn't it? That makes it so easy, yeah? And then it just is accessible like a dictionary. 1 minus 3. And what I'm thinking of for a solution is we just want to minimize opposing directions, or opposite directions, yeah. Do we even need to iterate through it though? Or can we just use, I don't know, like a sort of greedy algorithm instead of brute force? Because we already have the directions, it doesn't really matter. Does it really matter what order they're in? Oh, it does. Because this can be at any time. Maybe I'm just doing it all wrong. Maybe I'm just thinking of the resulting solution. Or the resulting distance. Is it really just brute force? I don't believe that it's fast enough if it's just brute force and you're using. If this is recursive, there's no way I'm solving it. I really don't want to look at a solution, but I can't seem to wrap. feel like there definitely needs to be a for loop. So you would change to be north. Okay. And you would change this to be south to north. So what if we for character and string, so instead of what if instead of using this counter, I think we actually want a counter that we make ourselves, just so we can update it as we go through the string. So and we obviously want a variable called result, which starts out as 0. Actually, I don't think that might be the case. I think actually a counter would be quite useful. And then we can do max vertical equals max horizontal equals here, and then we can use a couple if statements. If or max vertical equals west if char counts west is greater than char counts east. I guess we don't even need to initialize, and then this is just the same with max horizontal. Max horizontal would be, oh, I'm stupid, aren't I? It's north and east, north and south. And then we could do east. And then else south, else west. And then print next vertical, next horizontal. South and west. And this one is west and south. Sure. Okay. Well, k is greater than 0. Well, k is greater than 0 and I guess we can have one this variable is going to keep track of the difference between each opposing direction. So for instance, in this second problem, you have 3 west, but you only have 1 east. So the difference between these directions, or the horizontal directions, are going to be 3 minus 1, which equals 2. And obviously you want to minimize this difference to get the maximum result. Horizontal or east minus west. Okay. Actually, I want to print this out first, so let's just comment this out. What? Comment this out. Vertical difference, horizontal difference. Zero, zero, that should be the case. Zero, zero. That's true. You wanna maximize. You wanna maximize the difference, right? You wanna maximize the difference. Oh, this is a tough problem. I think I'm kind of running in circles here. I think I need to view the solution. Okay. Answer equals 0. And then north equals south equals east equals west equals 0. For I in range length of S, C equals S of I. What is C? Current. If current equals north, I think a better solution is actually to have what I had, which is directions equals north B1, south B minus 1, east B1, and west B minus 1. And then you can just do but I guess that's true. I guess that's true. Okay. If C equals north, then north plus equals 1. LFC equals south. South plus equals 1. LFC equals east. And east plus equals 1. And finally, LFC equals west. Then we add 1 to west. So this is just a counter for each direction. X equals absolute value of north minus south. Y equals absolute value of east minus west. What is ND? Current Manhattan distance. Distance equals x plus y. What is 2 times k? What is this formula? Distance. Minimum of 2 times k. I plus 1 minus md. Oh, this is what? Oh, oops. South, and this is also south. Oh, oops. Okay, now we definitely need to see what's going on with that formula here. Okay, so you keep a counter of all of them, yeah. X equals this does not make sense. Shouldn't X be in the horizontal directions, which would be east and west. Does it work the other way around? Yeah, it does. I don't know why it had X being the vertical directions, but sure. Oh, they had it right here, just not in the solution. The potential increase is 2 times k if all changes optimally increase MD. However, we cannot change more directions than movements processed. I plus 1. Hence the actual increase is 2 times k, or I plus 1 minus MD. I plus 1 is the number of movements processed. MD is the current distance. The difference is the number of changes needed to align all movements in the same direction. Two times k max possible increase from k changes. Sure. How much room is left to reach max possible MD?
The N and S at that we have two combinations.
Hmm. Keep track of all direction counts. Could you just make this? Could you just do a dictionary instead, though? Direction count equals north 0, south 0, east 0, and then west 0. And then instead of doing all these ls statements, you can do direction count if directions equals north equals 1, south equals -1, east equals 1, west equals -1. So direction count of C plus equals directions of C, right? This is just saying we're looking in this array. If our current one, we're just going to mark our current one. So if our current is at S, okay, we're going to be either adding or subtracting to this. And then we're also looking at directions. So we're going to be looking at the values of these. And we're going to be either adding or subtracting these values to these counts. That should work, I believe. Probably need a just direction count and directions. Direction count and then D. Just direction count east minus direction count west. Direction count north minus direction count of south. And should that be it? Oh, what did I do? How is this different? Plus or minus, plus equals. Why is that not the same thing? Why does this not do the same? when you get north, DC of north, is that not? Oh, wait, so should it just be this? Yeah? Okay. Interesting, interesting. Is that what chat does? Yeah. That's what chat does. So we have a count array or a count dictionary. We probably don't need C. S of I. I don't know. This is more readable to me at least. And we can just this seems more readable to me. Still not easy to understand. Initialize it, initialize the count. So keeps track of direction count. Add 1 to the direction. Calculate current X and Y difference. So I had the right ideas, I just wasn't able to execute, and I definitely did not get this 2 times k I plus 1 minus md thing. Computes distance from changing directions. Not happy with today's problem. It's always so much sweeter if you actually do the problem yourself instead of looking at the solution, but I get it. I'm only 15 days into this series, so I'm not going to be able to solve these harder mediums and hard problems quite yet. That's why I'm on the grind. Two times k, because each flip adds to distance, adds twice the distance, because if you have north and south which cancel each other, making it 2 north would just be 2 instead of 0. I plus 1 minus md. Well, let's see what these crazy people did. This is not sexy. Like yesterday's problem, I found a sexy solution. That was, I mean, sure it's fast, but like you know, it's just so many FLs. All right, that'll be it for today, guys. Peace.